Hi, today I'll be talking about geophysical methods, and today we're going to start with the gravity method. So gravity is using the changes in density in different rock types to tell us what the different rock types are in the subsurface underneath the Earth. So we'll have rocks with a higher density will give us a higher gravity field, and rocks with a lower density will give us a lower gravity field. And as we take measurements on the surface, we can put these into the computer and create graphs of the gravity field on the Earth's surface. The gravity method depends on the density of the rocks. And here we have two rock samples that have different densities. This rock is a pinker rock and it has a lower density, whereas this rock is a black rock and it has a higher density. So it will weigh more. So we can see when we hold it, it's heavier. And in the field, when we go out and take measurements, we'll take gravity measurements, this rock will have a higher gravity and this rock will have a lower gravity field. So the measurements will be of higher intensity here and lower intensity here. So here's an example of a rock that has high density dark rock on the bottom, which contains platinum, and lower density lighter colored rock on the top. And this contact would be invisible if we were underneath cover. And so what we do is we do a gravity survey where we take measurements all over the surface to determine where that contact is that is now hidden by the covering. So underneath it, we would have the dark rock with platinum in it and the light rock without platinum, and that's what we want to find, and it will have a higher gravity measurement. It's very important while we're in the field that we take good notes. We need to record the location of our measurement and the value of the measurement, the time of the measurement, and any other notes about it. So what we've got here is a field notebook, and she's writing down the various columns that we're going to use to write down the data. Another way to record measurements is on your cell phone, and that can be electronically and then downloaded later at the office to make your map. It's important to take down the following information. We need the station number, we need the reading on the instrument, we need the time of the reading, we need the location of the reading or the waypoint, and any comments about the conditions in the field that might be available. When we take gravity measurements in the field, we start at a base station. And the base station should be on solid rock and very, very stable. And we move from the base station to different field sites all around the field, but we come back to our base station and repeat our measurement. And the reason for that is due to the solid Earth tides. The Earth experiences tides just like the ocean does. Where the ocean goes up and down, so does the solid Earth. The solid Earth tide is about 40 centimeters high, but we can't actually feel it standing here because the wavelength is several thousand kilometers long. But the gravity meter is sensitive enough to measure this small change in elevation over this long wavelength. So what he's doing now is setting up the gravity meter. The first thing to do is to level the gravity meter and make sure it's on a solid foundation. So we put it on the tripod and we make sure the tripod is level, and then we put the gravity meter on top of that. First we press the on-off button and wait for the instrument to start. Then we can adjust the station numbers, the line numbers, and the elevation. We can edit the lat long and the UTM. Now we want to level, so we push F5 for the leveling. We see if it's level to within -2, +2 on both the X and the Y. Okay, and once the numbers have settled down, then we can press measure clear. Okay, and it will start measuring. The blue light will come on the front of the instrument, and that means it's going to start measuring. And there we see the numbers coming up. And it will take measurements for 2 minutes, and we can adjust that if we need to, but for right now it's set on 2 minutes. And then when you have enough measurements, so we can go ahead and stop this reading. Okay, and then push final data. And that gives us the current reading and the preceding reading. And we can push record and it will keep it. F5, yep. Okay, and we move on to the next station. It automatically increases the number usually. And so we can push level and make sure it's still level, and then measure clear. And there's our next measurement. It's ready to take it. And as soon as the blue light comes on, it takes another measurement. There we go. Okay, and each time in between, we move the gravity meter. Okay, this is just an example standing still, but normally we would move it for each measurement. Okay, and we can go ahead and stop. So the gravity method is a very, very sensitive method. It can measure changes of elevation of only 3 centimeters. We can use it to find resources in the subsurface of the Earth, such as minerals, water, and even assist with archaeology expeditions.